Welcome to Maths for All. I'm Aisling Flynn. This is Statistics 1.5, Measures of Spread. So the first measure of spread we're going to look at is the range. And the range is the difference between the greatest and the least values in a data set. So the difference between the biggest and the smallest, the greatest and the least. Okay, and it gives a description of how the data is spread out. So are they all bunched together? You get a small range if all the values are very similar. If the values are very different, going from very large to very low numbers, well then you'll get a large range. So here's an example. The heights of 10 students were recorded. What is the range of their heights? So here we have them in no particular order. So that is something we have to sort out first. So the question is easier if we rank the data. That means putting them from smallest to largest. Okay, and there the numbers are ranked. And now we can see that the smallest value is 1.54 and the largest value is 1.79 meters. So you identified the greatest and the least, which we've just done. Okay, and then to find the range we find their difference, meaning we subtract. So 1.79 minus 1.54 gives us 0.25 meters or 25 centimeters. So this is telling me that the students in that group are all within 25 centimeters of each other in height. Okay, now I want you to pause the video, and for each of these 4 sets of data, I want you first of all to rank the data and then to find the range, and then press play for the results. Okay, so number 1, did you rank and get these values? 5, 5, 9, 9 and 12. Okay, we have our greatest and our least. So 12 minus 5 will give us our range, and the range is 7. So did you get 7 also? Number 2, to rank that, we have 6, 12, 12, 13, 16, 19 and 20. Okay, the greatest is 20, the least is 6. 20 minus 6 will give us the range, which is 14. The third one, did you rank and get 6, 7, 7, 14, 18 and 20? So there's the greatest, there's the least, subtract 20 minus 6 and we get the range. So we can see that numbers 2 and 3, those exercises have the same range, different values, but the same range. Okay, and finally to rank in question 4 we get 9, 10, 11, 11, 12, 13, 15, 17 and 19. Okay, there's the greatest, there's the least, so 19 minus 9 gives us a range of 10. Okay, so that's the range. So we can see the numbers in question 1 are closest together. Okay, followed by question 4 and then the 2 and 3. Okay, here's a little rhyme you'll find on the internet to remember your averages and also your range. It goes, hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one you see the most often, and the range is the difference between. So if you like that, you can use it to help you. Okay, so continuing with range. So it is a measure of spread. Are the numbers very close together, or are they wide ranging from small, very small to very large? Okay, the range can be used for numerical data, obviously because you have to rank them from small to big. When there are many values, the range is quickly identified, so that's an advantage. However, the range can be skewed by outliers. So if you have the addition of one very low number or one very high number to your data set, it will change the range completely. We'll see that in a minute. Okay, so the range and outliers. So returning to the example we had for measures of centre. A driving test centre had 4 tests one morning. The ages of those being tested were, and it's already ranked, 17, 18, 19, 21. What was the range of ages? So you can see they're very close together. Okay, 21 was the greatest, 17 was the lowest, so 21 minus 17 gives us a range of 4 years. Okay, so very small range, and you can make a generalization about the people going for their driving test. They're very young people, 17 and up to early 20s. Okay, so just about when they're eligible to go for their test. Okay, now the 5th person to be tested that day was a retired person with learning to drive on their bucket list, so they hadn't learned before now, and they were 68 years old. So calculate the new range. All right, so we have a new highest value, which is now 68. So it would be, if we're to add 68 in there. Okay, so 68 minus 17, and we get a range of 51 years. So that implies that people of all ages are going for their test that morning. People whose ages are spanning over 51 years. And really that's not true. There's just one person who skews the data. Okay, most people are quite young. So sometimes the range may not be a suitable choice to describe the spread of data. Okay, for this reason we may wish to use something called the interquartile range instead of the range when outliers are present. Okay, so let's explain that. Interquartile range. Now it's a little bit as the name suggests. Inter we'll say it's in between. Okay, so I'm just going to use the word to help us here. So or in between. Quartile, it's something to do with quarters, or it's 1/4, and we do use range, which is a max minus a min, so the largest minus the least. Okay, so the range can be skewed by outliers. To avoid this, we can look at the middle half of values only. Okay, so the middle half, I'll underline that, we'll return to that in a minute. To avoid this, we remove the bottom quarter, okay, or the first quarter. We'll return to what's known as Q1, okay, later. Okay, so we take off the bottom quarter, or bottom 25% if you like percentages, and we remove the top quarter. So it's from the first quarter down and the 3/4 mark up. Okay, we'll revisit Q1 and Q3 in a minute. So you're taking from the 75% mark upwards. Okay, so we remove the first quarter and the last quarter of the data, and what you're left with in the middle is the middle half, the 50% in the center. Okay. And then when we get the middle half, we look at the biggest value in the middle half and the smallest value in the middle half, and we get the difference between them. And this gives us the interquartile range, sometimes written IQR for short. It indicates the spread of the middle 50% of the data. So it will tell you that half the people are between this value and that value, and it gives you an indication of where most of the data is bunched together and without taking into account outliers. So we best do an example and see how it's done. Example: the following are marks in an English exam from a group of 14 students. There you see their marks, and they're in no particular order. So what we better do first is to rank the data, and that's done for us there. Okay, so you can see the range is from 32 up to 91. Okay, some people didn't do so well, some people did very well, but if you look in the center of the list there, there's a big bunch of people in around the 50s and the 60s. Okay, so we're interested in those really. So what we must do now is remove the first quarter and the second quarter of data. So first step is to find 1/4 of 14. How many make 1/4 of 14? Okay, so 14 divided by 4 is 3.5. Now you can't remove 3.5 values, okay? And the definition, when you look into it, of the interquartile range is that you must remove at least this much, okay? So we must remove at least 3.5 values. So that means basically we must remove 4 values. So we're always overestimate from your number. Okay, so if you get an answer of 3.5, all right, 3.5, 3.6, but equally 3.1 or 3.2, you must always remove 4 values, okay? Because the definition says we must take away at least this much, okay? So always go higher is the point here. We will count in 4 values from the top and the bottom, okay? So we'll do that on the next slide. So counting in 4 values from the bottom, we get to 53. Counting in 4 values from the top, or counting back, you get to 78. So that's 1, 2, 3, 4. Okay, and you do the reverse from the top. 1, 2, 3, 4. Okay, and you get your 53 and 78. And we call 53 Q1. Okay, that's the first quartile. There is at least a quarter of the data below that, and there's at least a quarter of that data above 78, which is known as the third quartile, Q3. Okay, and to get the interquartile range, so the range between the quarters, we do Q3 minus Q1. Okay, if you want, Q3 minus Q1. So 78 minus 53, and we get 25. So 50% of people are within 25 marks of each other between 53 and 78. Okay, or half of the people, half of the data are in that range. Now, so here's another example which is slightly different. We'll see why in a moment. The following are temperatures recorded in Berlin over 16 days in January. Okay, so there we have 16 pieces of data, and as always we'll rank them first, okay, from smallest to largest. And there we have it from 1 degree up to 8 degrees. Okay, so we want to find the interquartile range, so first we must know what is a quarter of 16. Okay, so we do 16 divided by 4 equals 4. Alright, so if we were to use the 4th value in and the 4th value from the top and the bottom, we're not guaranteed that a quarter of the data is outside of that. Okay, so just like before, we must remove at least this much data from the top and the bottom. So we will count in more than 4 values from the top and the bottom. Okay, and you'll see what I mean by that in a moment. So if you get a whole number when you divide by 4, we must go further than 4. Okay, and you'll see that now in a moment. And just remember, always go higher, always overestimate. Okay, so to count in 4, you would get to the number 2. Let's see. Where's my pen gone? Okay, so you get 1, 2, 3, 4. We end up here, and the same from the top. 1, 2, 3, 4. We'd end up at the 6. Okay, so we must go more than that. So I'm drawing a line after the 2 and before the 6, and these will be our Q1 and our Q3. So what do we do next? When the 1/4 mark falls between two values, like we see here, we take the halfway value, so it's similar to the median. Okay, so the quarter mark here is falling between 2 and 3. So you could add together and divide by 2, or what's halfway between 2 and 3? Well, it's 2.5. Okay. Q3 is a bit easier. What's halfway between 6 and 6? Well, it's the same, it's 6. Okay. So that's our Q1 and our Q3. And the interquartile range is gotten by subtracting those. So now it's time for you to do it. You've seen how to find the range, and you've seen how to find the interquartile range in two different cases. One where you divide by 4 and get a decimal, always round up, take the next value. One when you divide by 4 you get a whole number, always go a little bit further, so after the fourth value in our case there. Okay, so you've got a quiz and the written exercises, and here's a glossary.